So my name is Jared Burrows. I work for Microsoft. Specifically, I work on Yammer for Android. And this talk is about how I got Yammer's for Android actual DEX count down from 2 DEXs to a single one. We'll talk about many different strategies and things that I used. So the main motivation of this is because we have a lot of consumers that use us. Yammer, for instance, is a social networking service used for communication within an organization. When I first started this, we actually were supporting Min 15. Thank God we're not anymore. We have 3 split APKs. We support Min 15 and up, 16 and up, and then 19 and up. And that current 19 one targets 25. So thankfully, I was able to get us down to a single DEX when we were still supporting Min 15. So at least all those customers are still supported. So the reason why my main focus was to get rid of this is because I don't believe we should really have this. I think my big pet peeve is to get rid of multi-DEX for everybody. So that's why, at least in the target one, the actual implementation, the actual production APK that we send out to our users has a single APK. So when we were supporting the lower 15 through 18, and even 19, loading extra DEX files may lead to possible ANRs, as well as have a large allocation memory footprint when loading them at runtime. So the main focus of this entire talk is just 2 things: me lowering the DEX method count, and then lowering the actual APK size overall. So give like a sneak preview of my actual results. So before, when we first did this, post Proguard builds and release builds, we had 85,000 methods, which means it spilled over into a second DEX file. And the original APK size was 10.7 megabytes, and a little bit bigger than that. At the end of this talk, I'll show you how I got it down to after 60,000 methods, almost 61,000, and the actual APK size down to 7.1 megabytes, which is a 33% reduction, which is, I think, pretty good. And the method count is really what my main focus was. It was a 28.4% reduction. So what makes the APK so big? I would say having more than 1 DEX file, especially 3 or more, especially in debug builds, it slows down debug builds very much so. So I think also having plenty of resources. So we'd be going through different strategies on how to slim our APKs down. So it makes an APK. Of course, we have our Android manifest. We have a lib folder that contains native code, and thank God Yammer does not contain native code. We have assets. This contains raw media such as font files. We have a classes.dex. Currently, we used to have 2, and we'll get into that a little bit later, but right now we only have 1. And the res folder, which we'll talk about trimming down, contains our resources such as Drawables, layouts, colors, you name it. And then we have a meta.imp folder that contains our signed application certificate, and then our resources ARSC, which is a file that contains precompiled resources from the binary XMLs. So let's moving on. So big APKs, let's focus on DEX size. So just low-hanging fruit, we want to go through our application and really remove all and any dead code, which should actually never get gotten in the first place, right? We also want to remove any old and unused libraries, as well as factor out any large non-mobile first libraries. And then one important thing I see on Stack Overflow quite often, and what I actually saw in one instance in our build when I first joined Yammer, was make sure our Gradle configurations were actually scoped correctly. So resources. So this is pretty simple. So we want to trim down everything in the res folder and the assets folder. And we'll get into that in a little bit. So res folders contain our layouts, PNGs, string files, and then, like I said before, assets contain the raw media, fonts. So I just want to show some people some metrics before we actually get into this. So in the debug build, had 113,000 methods, which is way too much. I mean, a little bit more than we almost had 2 to 3 DEXs just for a debug build. And our debug builds, which is the developer builds, the ones we do not ship, was 12.3 megabytes. I think that's a little insane. I think we could do a lot better in moving forward. And by the way, the 2 plugins I use for this are which I'll explain about later, is the Keep Safe DEX Count plugin and Venetech's Gradle Android APK size plugin. And I showed you the correct commands. So this is our initial release build with Proguard before any of my optimizations. So like I said before, we had the 85,000 methods, and you can see that we were able to shave about 2 megabytes, 10.7, from the actual 12.3. So we were doing pretty well with our basic build, but I think we could do a little bit better. And that's the final results before I started doing anything. So now we have a baseline, we can actually move forward. Optimizing the DEX size. So here we'll talk about all my previous bullet points, as well as tools, and eventually at the end how to automate this and really look into preventing this and really getting your team to really think about it. Especially as your team grows, we really want to think about how to prevent this in the future. So trimming the DEX size. So for us, removing all unused code. We use tools, basic tools that come with Gradle, such as PMD, to find unused code. Of course, we use Proguard And we'll get into that a little bit later. Of course, we also use IntelliJ/Android Studio's inspections, where you can actually just click Analyze and then inspect your code. It'll find bad use cases, old code, things that can be updated or removed. We'll see an example. So when we went to actually remove unused libraries, we came across where we were using something called Application Insights, and we were using HockeyApp at the exact same time. So in this case, Microsoft owns both of these libraries, and they're both open source. You can check them out on GitHub. But Application Insights has since been deprecated. And, well, actually, at the time, it was not deprecated. But for this talk, it is now deprecated. But we found out the way we were using Application Insights, we could actually just use HockeyApp because it encompasses Application Insights functionality. So the takeaway from this is to be able to pick and choose and seriously make sure you pick out the libraries you need and don't use one library per use case when you can use HockeyApp in this instance that encompasses both functionality for both of them. So that's really what we did for removing a lot of dead code. Stepping forward, removing old libraries. This is kind of a big one and very interesting one. So we also found another library called Android Query that just did version checking, which we actually roll all of our apps, through nightlies at least, through HockeyApp. And so we were actually able to remove this one quite simply. Another big benefit, I would say, of removing old libraries, actually really unnecessary libraries, in our case would be, I think it's very important that you do not pick out libraries that duplicate Android's existing functionality. I believe in Min API, I want to say 9, they had the patterns for regex for verifying emails. And I saw there's an instance that we were using Apache Commons Validator to validate email addresses that had quite a bit of methods, and the jar was pretty big. So I was actually able just to remove that, and it gave us a little bit of a reduction. Here's a common case I want to talk about a little bit that has to do with transitive dependencies and Proguard. So we have a little bit of context. We have a multi-module build for Yammer, and the reason that is because we refactored our entire code base to MVP. So most of our modules are pure Java, and they build much, much faster than our actual UI APK module. So during this time, we didn't have a single way of versioning all of our different dependencies. So there was an instance where there was a version of Jackson 1 and Jackson 2 used at the same time, in which you would think that Gradle would pick the next version. However, Jackson 2 has a brand new package, similar from going from ArcJava 1 to ArcJava 2. So Proguard can't really do its job. It could just Proguard Jackson 1 and Jackson 2. They're not interoperable. So what the other takeaway here is that you want to be able to have some way of tracking what dependencies you're using. You don't want to duplicate the functionality between two different libraries that essentially do the same thing. And because of this issue, Proguard couldn't do its job. So let's talk about this. So the main issue was actually transitive dependencies. So what happened was we were using Jackson 1 in one module that hasn't been touched in a very long time by our development group. And then we have Jackson 2, and we're actually bringing in JSON, which came up with a second problem, which was transitive dependencies. There wasn't anyone really checking the transitive dependencies, and it was coming in. So we need a way of making sure and checking those before we actually bring in newer libraries. So we can use Gradle dependencies to see these transitive dependencies, but we actually need a way of making sure we don't use the same dependency of different versions, in which we talked about Jackson 1 versus Jackson 2. So how do we solve this problem? One common thing you may see on GitHub is something that we've did in our local repositories, and this is what I do in all my personal projects on GitHub as well. I have a versions like Gradle file in this current project in which we apply our external properties for this example, a support library version, and then we can apply this variable in a dependency map, and where we use the artifact ID for the actual key, and for the value we use the dependency itself. And then we can go ahead and apply it in the dependency block just like this. I think this is pretty standard common practice right now. It allows you to keep track of your dependencies, and this will prevent you from adding Jackson 1 and Jackson 2 as an example, which is this same library, but one's a newer version, but there's no way to use Proguard or anything to strip it out because of the package name differences. And to solve the transitive dependencies problem, here's an example. Basically, we have different modules such as Yammer Common, Yammer Data, Yammer UI, and a few other things where we break up our code, helps with speed. In this example, we see that we have JSON in one, latest version of JSON, and an older version of Retrofit, which back in the day used to bring in JSON and would get auto-bump the version. And then we also have an internal Microsoft library that's also open source that we're forced to use that also brings in JSON, which brings me back to my previous point about how we vet and actually check on libraries. So before, in a previously old module that we haven't touched in a while, we were using Jackson 1, and before I found it, then I bumped us up to Jackson 2. And we also had Jackson 2 being compiled into our production code. And it turns out, through a transitive dependency, Retrofit was also bringing in JSON, which just let you know, Retrofit 2 no longer brings in JSON. So the true win here was removing Jackson 1, figuring out now we have not 3 libraries that did the same thing. Now we only have 2. We have Jackson 2. We actually bring in JSON. And since Jackson 2 is pretty much overkill, I would say on mobile applications, we're actually able to remove Jackson 2 for JSON, in which our current production application is using JSON instead of Jackson now. And that's one of the major factors of how we got down to a single DEX, because Jackson's so much bigger than JSON itself. Yeah. So one thing going forward, after all that, I really push on my team to check for and make sure that we're doing certain things, is checking the size. Now, just to let everybody know, the method counts that I display here are very close to the latest versions of the libraries. But one thing to take away is this is pre-DEXed, which means there'd be more methods potentially added in, and this is pre-Proguard. So don't think of this as being too scary, because once you add into your application and you use Proguard, it would essentially take away most of these, and then you should be able to retain only a certain amount. But one thing we did have was like Guava, which had 15K plus methods, and we were using Jackson. One tool that I use is MethodsCounts.com, and I'll show you a picture of that in a second to help like vet and choose, make sure certain libraries and their transitive dependencies before we go ahead and add them in. But of course, like most of us in the room, we have necessary evils, such as AppCompat, Google Play Services. So here's an AppCompat version we're using. It already comes with 16K plus methods, which also brings in other transitive dependencies such as support library 4, annotations, and a few others. And then we're only using GCM Google Play Services. Thank God, it's already so big. And as you can tell, just simply adding AppCompat and Google Play Services, you're already at 30K plus methods, which are very close to the DEX limit, which is around 65,000 methods. So here's a picture of MethodCounts.com. You can simply type in the library that you want. It tells you the current method count of the top level dependency, and then gives the method count of the transitive dependencies. I found this to be very helpful. This also comes with the Gradle plugin if you want to try it out. Like I said before, we have an actual jar size .kb and actual DEX size, and then we actually have the jar size and then the DEX size. So it allows us to like choose and pick and choose to make sure that we're actually choosing a dependency that I would consider making sure it's mobile first. Or I would say like things like Guava or Jackson may not have a Android in mind. So one common question I see on Stack Overflow a lot, and an instance that I saw in one of our modules before I fixed it, was that when you have multi-module builds and you have a common source set, or a common project that you use across all your sources, a common project that you use across your projects, if you have something like common tests that you use for all your tests, especially for like UI testing or unit testing, it's very important that we do not put it into our main compile configuration. So we make sure that our current project are scoped correctly. So in this example, which is a pre-Android Gradle 3.0 example, you can see that we have a common test project that's actually getting compiled into our current project. So what we want to do is make sure that this never happens. And of course, some of you might say that Proguard or other tools may see that this is not being used or implemented in an actual app itself, so we'll be able to actually remove it. But we don't have to go that far. With a little bit tracking, we can actually just go ahead and make sure that we focus on this and then use the correct source set, test compile in this case. And then of course, this is we use the latest stable plugin 2.3.3. So if we're going to move forward, these change to like API and test implementation. The reason I use API here is I want comment to be absorbed and consumed by other modules, and then test implementation is just for test scope and shouldn't be consumed by anybody. So I just think the major takeaway is to make sure that we're using correct Gradle scopes when compiling projects. So of course, the major freebie that you have, I think that comes to the Android Gradle plugin, is Proguard. We use Proguard because of the amount of code that we have and the amount of code that's generated, as well as the dependencies that we have to bring in. One really cool thing is to see is that now, for a while now, Android has always provided us the Android SDK, Proguard Android Optimized, as well as Proguard Android, but now this is baked into the actual plugin itself. Currently right now, we use Proguard Android, something in the future we may look at a more aggressive approach, but that's not really a priority right now since I already got down to single DEX. A more aggressive approach would be Proguard Android Optimized, which effectively runs Proguard, I believe, about 5 times, or the optimization passes 5 times. So let's take a look at an example. So here's a snippet of a common build.gradle file where we have minified enabled, and we want to set that to true. But next thing that we need to make sure we have is obviously a signing configuration for the release build type, but also we want to make sure that we have the correct Proguard rules. So you always want to at least add in the default Proguard file from the actual Gradle plugin, such as Proguard Android, and then of course add in your custom Proguard rules as well. And if you really want to go a little bit crazy, you can go ahead and optimize it, or use the optimization one. But I'd be very careful with this. It's a lot more aggressive. As I said, it runs Proguard effectively 5 times, or the aggressive pass 5 times. So some of the things you can do with Proguard would be simply to remove extra Proguard rules. I would say keep them up to date with your current libraries that are actually in your app. So when you add or remove libraries, make sure you update the existing ones moving forward and remove the older ones also moving forward. Another takeaway is to make sure you use keep sparingly. This is also something I see very common on Stack Overflow. And let's move to an actual example. So here is actual example taken from OKHTTP's GitHub. Someone asked, what are the current Proguard rules? And because they were moving from like OKHTTP, I think 2.0 to 3.0. And if you know how the source code looks and the way it's packaged, you don't want to overmatch the rules. So the takeaway here, I would say you want to make sure you use keep sparingly. So right here, we're keeping every single class, every single interface, and then we're saying to ourselves, we no longer care. We just want Proguard to be quiet. We don't want us to warn us or give us any notes. So I say that we focus on these last two lines. And I think that we should, like I said before, use keep sparingly as we move forward. So personally, in our personal project at Yammer for Android, we actually do not use these first top two rules as we've tested it, as well as the answers on the GitHub issue where I found this is simply just moving forward, let Proguard decide. You don't want to overmatch, just go ahead and let it do its job. So moving on. So before we talked about all the slides were what I did to help optimize on the Java side, actual code implementation side, optimizing the actual DEX and reduction. This helped get us down to single DEX, but what else can we do moving forward? How can we continue to make the APK a little bit smaller? How can we shrink it? What else can we do? So the first thing I love, quite honestly, is automating Lint. The first thing I think we should do is fail when there's a Lint issue. Any projects that I work on, inside or outside of work, I always try to make sure that Lint is optimized for compatibility issues, as well as if you use like a Gradle plugin or library, that when you implement it in your app, it doesn't bring up any issues in your APK. So one thing that we did at Yammer was to make sure we have no unused resources. And what we did with that was simply failing to build via unused resources. Now, one takeaway here is if you're building a library that's obviously a jar, you won't have this issue. But if you're building an Android library that's an AAR, an Android archive, you should keep all your resources because you don't know who's going to consume them for the APK. So, like I said before, we considered failing the builds on Lint, but if you have so many unused resources, it's going to be a little bit dangerous. So how do we do this? So here's an example of a build at Gradle that uses Lint options that dump out everything to the console using a text report true and text output std out. I build everything via command line, so it's really helpful for me when I was going through and pruning a lot of these issues. I always turn on all warnings and force them to be errors. That way we fail right away, we fail fast, and continue to move forward. And if you think it's a little bit crazy, we can actually not make this so painful. We can actually say error unused resources and just specify this single one to actually fail. That we can go through and prune them one by one, which is effectively less strict. All right, moving forward. So another really freebie I would say that comes with the Android Gradle build tool is enabling shrink for resources. When Lint doesn't find everything, you really need to go through and manually find stuff, such as the assets folder. So at Yammer, before we came there, it looks like there was a bunch of font files that were unused, specifically Roboto fonts, and we were actually able to get rid of the majority of them, which saved about 2 megabytes of binary data that was just packaged in the app in the assets folder that was being loaded into the app. That was not being loaded into the app, and so we were able to actually just easily remove it. And things that Lint couldn't find or you couldn't find, ShrinkResources hopefully will find. So at least have 3 gateways in which to make your APK a little bit smaller when it comes to resources. So let's go see a little bit of an example. So here is our previous Proguard Android optimized example with minified enabled and our custom Proguard rules. Let's go ahead, and this is missing ShrinkResources. Let's go ahead and add it. It's very simple. If you have minified enabled true, which means you're running Proguard, you can go ahead and take it to the next level and add in ShrinkResources equals true. This will continue to prune your APK and make it a little bit smaller. Next step I found very helpful is that since most of us that we use like Google Play Services, AppCompat, we may not need to use or want to compile all the different strings.xml files into our actual end user product because we now support all these different languages. At Yammer, we support many different languages, so this actually didn't help out as much, but there was a few kilobyte reduction, a few hundred kilobyte reduction. So let's see a little bit of an example. So say we have multiple AARs that bring in different localizations. Here we can strip out and force out any language and only keep English in this example. But luckily, it's a list and takes multiple strings. And we can specify English, German, and French. And we can specify any kind of configuration that we want to keep. And this is really helpful, especially if you're bringing in different AERs that are third-party and support multiple localization, but you don't want to bring in all those other localizations. So this one was a little interesting. So packaging options, I believe back in the day, didn't always support regex, but now I know in the latest DSL, I know for sure that it does. So basically when jars get merged in to your current project, usually they'll shove in a bunch of like meta-inf files or license files or notice files or small little binary datas or ASCII text or whatever have you into your actual APK. And you probably don't want that shipped. Maybe only keep it locally, but maybe when your actual APK goes to your actual end user, you want to strip all that stuff out. So one little tool that you can use is Android Studio's build and then click on the APK inspector. You can click build and then click on the analyze APK, and you can figure out what you want to keep and what you don't want to keep. And then you use packaging options to effectively filter out these files. So when it comes to ShrinkResources, I'm sure everyone's seen the Stack Overflow. You usually have a duplication of like this meta-inf license file, like meta-inf notice file, and then it's like the top answer Stack Overflow. You just go ahead and say pick first or exclude. Usually everyone says exclude. But my question is, what are we excluding? Let's go ahead and take a look at this. So, excuse me. So say if you use Android Studio and you look into the build and you want to look at, analyze your actual APK itself. Back in the day, you actually had to like unzip it -L and look at all the individual files. But now there's actual visual representation. And you can see in my debug build here, I have multiple class files, which will be one very shortly here. We minimize the res folder. How can we strip out extra files from meta-inf? We've actually stripped out some files from assets earlier. I believe OKHTTP3 brings in this public suffixes.gz. And then just recently we moved to Kotlin, or slightly started moving to Kotlin, in which our APK now contains a Kotlin folder, build.data properties, and other transitive dependencies that bring in other binary data folders, such as like JSR 305 annotations and this org folder. So like I said in the previous slide, now that packaging options allows us to use regex, we can help automate and clean up all of these in our for our end APK before we ship it. So here's an example where I'm going through and filtering out anything from the Kotlin module, anything from the Kotlin folder, and then instead of manually specifying exclude for every single property file and manually specifying everything for XML and text, we just go ahead and use regex to strip all this stuff out. This only saved us like 15 kilobytes, maybe an over optimization, but in my point of view, I think that anything in there that we didn't put in there or agree to put in there, I just think it would be nice to pull it out. So this is what I consider very strict packaging options. So here, we'll take a look again after we build our release version, or actually, this is our debug version, because we see two classes.dex. Now we stripped all this stuff away, and it looks a lot cleaner than it was before. So one major thing that seemed to help us out a lot at Yammer, we had a lot of PNGs. And it got to the point where every time we were talking to the designer, they had to resize the PNG to like 4 or 5 different sizes based on the min API levels that we're supporting. But now since we're like supporting API or min API 9 and up, and we're using support library of 25, we can use vector drawables pretty safely. Because there used to be there used to be a bug in 23, so we couldn't move to it just yet. Then when support went to API min of 24, we're actually able to use it. And it helped us get rid of all the PNGs, a lot of the binary data from actual Git repository, and move them to vector drawables, Android vector drawables. So any like simple PNG, such as like a menu icon, can be easily converted through the IDE. And we work very closely with our designers. Use a tool I believe called like Sketch to export out an actual SVG that's pretty simple. And then us as an Android developer, we go ahead and use SVG to Android or other such tools to help us convert simple SVGs to Android vector drawables. So let's take a look at that. So first, you want to make sure you're using at least API 24 and up for the support libraries. And then here is our optimized resconfig E, English, German, French, or whatever have you want to keep in your project. Here's that example. But now we added something new. We added vector drawables, and we want to make sure that we're using the support library equals true. And what this does is it prevents it from looking that you're using actual vector drawable and then generating for min API 19. Or sorry, if you don't have it set to true, excuse me, if you don't have it set to true, it'll generate those PNGs from the XML files, which defeats the whole purpose of moving to vector drawables in the first place. But since we're using vector drawables via the AppCompat library, we want to go ahead and turn this to true, prevents the extra drawables, and now we're just using a single XML drawable that can be used at any size, any DPI. It's really helpful, and it's helped us reduce a lot. And I believe that there's a few PNGs that we can still move over in the future. So here's a tool called SVG to Android. I find it very helpful. Many of the UI-specific projects I've been on at Yammer, I've used this tool many times. It helps out quite easily. Once again, it's really nice if you're working with a designer who just hands you an SVG instead of PNG directly. So here's, it's very simple. It's drag and drop. Once you drop it into here, you can copy and paste out the vector drawable, and you can simply paste it into your project. So here's an example of what a resource file looks like when we're actually going to add these vector drawables in. We have two image views with two different drawables, circle and hello. And we want to focus on the namespace of Android. And you can see that the two image views here are Android source. This right here will not load with us. Will not load the vector drawables with the source library or the AppCompat library as we would like them to. So we want to take a step forward and make sure we have the namespace for the AppCompat in there with app, and then namespace it correctly and use source compat. That way we're actually using the vector drawable and not the previous PNG beforehand. And now we can simply delete those PNGs. Yeah. So now I kind of want to get into, after we did all the DEX stuff, after we did all the resources, after all the optimizations, what have we actually gotten down to? So here's the optimized build that we have today. Before it was about 113,000, and currently right now it's about 100,000. Now we've done a lot of different, we added several different libraries into the debug compile configuration, which means our debug is still pretty big because we do a lot of testing with debug, which is perfectly fine. And the previous debug local build was about 12 megabytes versus 10 now. But here's the real win. So for our current customers and existing ones, anyone, because I already did this with API min 15 and 16, so everyone up to date will have a release build or final build of 60,000 methods, which is effectively about 61,000, which keeps us about 4,000 under the actual 65,000 limit, which gives us a nice little padding. But a major win I wasn't really expecting with all the resources, optimizing the resources, is that we have about 7.1 megabytes, which is a major difference from the original 10.7 post Proguard. So let's compare. So now, since we're under 64,000, we have one DEX file. Before it was 85, it would spill over into 2, and it got pretty messy. But now it feels pretty great. So now let's do a quick comparison. Like I said before in the previous slide, that so several months ago when I first started this little journey, before we were at 85,000, and now we're at 60,000. It was a 28.4 reduction, and then now from 10.7 to 7.1, it's about 33% reduction. So I think that was a major win for us. And but of course, as we slowly bump up the min SDK over time, which a big subset of our users are on 19. Once we bump up to 21, it won't matter as often. But like I said, I started this journey a long time ago when it was min API 15 and must have one for 16. So the last couple slides here, I want to go over automating these last two plugins. So here's a small example, a code snippet that someone asked about in one of the JIRA issues. I believe it was either KeepSafe DEX count or the Vanitex Gradle APK size plugin, but they're both very similar in the way they're written. So say if you run Gradle assemble release, and you want to force your maybe nightly builds or your health builds on your CI, or even maybe your local builds, but hopefully you don't run assemble release often locally. You can force the build to break if you hit a certain number of methods. So this is way over optimized. Currently right now, we're about 60,800 methods. So if you really want to go a little bit crazy or overhand, you can kind of pad it out about 61, 62,000 and really automate this. So anytime you run Gradle assemble release, you can break the build on method count. You want to go a step further, you can do something very similar with this other plugin that I like. It's the Gradle Android APK size plugin. Moving forward, if you run assemble release, you can force it to a certain megabytes. Well, actually, it's in kilobytes. And right now, we're about 7.1, so this is about 8 megabytes. So you can add a little bit of padding. That way, if something goes awry or crazy or gets too big, then you know there's actually something wrong, and you can fail your build with it. All right, and that's all I have today. Anyone have any questions? Yes?
One question. Well, a few questions. It's kind of awesome what you guys have done, but being at Microsoft, I'm just curious.
Yes.
have there been any internal questions, like discussions about using Xamarin, or because I know a lot of the libraries that expose the method counts. If you just convert those to C# using Mono, you kind of bypass a lot of that type stuff.
Yeah, that's a great question. So about moving to Xamarin, like moving to Xamarin completely from what we already have now.
Yeah, I mean it's a Microsoft type of system, so I was curious why.
Yeah, it's funny. In San Francisco, Xamarin just moved right upstairs next to us. So I mean, it's something that we've talked about and thought about. But our current code base is 6 years old, and there's a major optimization that I've done recently. So hopefully, maybe in the future, we could look into something like that. But I mean, just doing something like this took a little bit because I've work on my projects on the side and this on the side. But if we did move to Xamarin, we have to effectively do maybe chunk by chunk or pull out some of our current developers to help rewrite the whole thing. And of course, if we're going to do Xamarin and publish to iOS and Android, we probably have to talk to the iOS team about it. But they're in the process of using moving to Swift, so it's kind of like it's a little different. But I mean, yeah, I think it's a great question. I think it'd be great maybe to look into that a little bit more. Anybody else? Somebody else have a question? All right, cool. All right, well, thank you all for coming. Been pretty great.